A reaction rate is the speed at which a reaction occurs. And these rates are usually expressed in terms of change in concentration over a unit of time. So how much does the concentration change over so many seconds or minutes or hours? Typically, we represent it in units of molarity per second. So we're going to consider an acid-base reaction. Assume that we start a reaction by mixing sulfuric acid and calcium hydroxide solutions together, and the solutions have concentrations of 1 molar. The instant you mix these two reactions together, you'll start making water and calcium sulfate, and you'll start using up some of the sulfuric acid and calcium hydroxide. And it's important to remember that concentration is proportional to the rate of reaction. So the start of a reaction is always going to be the fastest the reaction will ever be. And as some of your reactants react, the concentration of sulfuric acid will go down and the concentration of calcium hydroxide will go down. And as the concentration goes down, because it's directly proportional to rate, the rate will also go down. We can plot concentration versus time and see how this works graphically. If the reaction starts with the reactants at 1 molar, those concentrations will continue to decrease as time goes on. The concentration will decrease rapidly at the start. You'll have a steep part of the curve because the concentration is very high and the reaction is happening very quickly. And as the concentration goes down, the reaction rate will continue to drop. Since a reaction rate is the speed at which a reaction occurs in terms of molarity per second, we can find the rate of reaction at any point along this curve. For example, in this reaction, I've made up a couple of numbers. I've said that the reaction starts at 1 molar concentrations at time 0, and the reactant concentrations have been reduced to 0.5 molar after about 0.3 seconds. We can calculate the rate of reaction in the time frame between 0 and 0.3 seconds by calculating the slope of the line between those 2 points. That is, we take the difference in concentration between 0.2 and 0.1, and we take the difference in time between 0.2 and 0.1. Or in pre-calculus terms, you take the rise over the run. And if you do this calculation, you find out that the rate of reaction, at least considering these made-up numbers, is negative 1.7 molar per second. And the negative sign simply implies that the concentration is going down at the rate of 1.7 molar per second. And that negative sign indicating the decrease in concentration is exactly what you would expect. Reactant concentrations need to go down. But the convention with reaction rates is to report all rates as positive values. So you're not allowed to write a reaction rate as a negative value. You have to convert it into a positive value. So the reaction rate for this reaction is best written as concentration is disappearing or reacting or decreasing at 1.7 molar per second.